Today I'll be presenting tutorial for cloud and beyond. In this short presentation I'll be covering four topics: the business benefits of cloud architectures, examples of cloud architectures, the service load balancing architecture, and redundant storage architecture. So let us get started. So, question 1 asks us to discuss the business benefits of cloud architectures. Cloud architectures offer several key benefits to businesses. First, they allow companies to scale their IT resources up or down based on actual demand, so there is no need to buy expensive hardware that just sits idle. Second, they follow a pay as you go model, meaning businesses only pay for the storage and computing power they actually use. This reduces wasted spending significantly. Third, because applications run in the cloud, the provider takes care of reliability and infrastructure. This frees businesses to focus on what they actually do rather than worrying about managing servers. Four, cloud environments are great for seasonal or temporary workloads, so companies can handle peak demand without permanently committing to extra resources. And finally, cloud services like SaaS, PaaS, and IaaS allow businesses to deploy new products and respond to market changes much faster than traditional on-premise system allows. Moving on to question 2, which asks for examples of cloud architectures. There are several fundamental cloud architectures. The first is workload distribution architecture, which uses a load balancer to evenly spread incoming requests across multiple virtual servers. The second is a resource pooling architecture, where identical IT resources such as CPU pools, memory pools, and storage pools are grouped together and allocated dynamically to consumers as needed. The third is dynamic scalability architecture, which automatically allocates or reclaims resources based on predefined thresholds. It supports horizontal scaling, vertical scaling, and dynamic relocation. Fourth is elastic resource capacity architecture, which dynamically provisions CPU and RAM through the hypervisor in response to fluctuating processing requirements. Fifth, we have the cloud bursting architecture. This extends on-premise resources into the cloud when local capacity is exceeded, and then releases those cloud resources once demands goes back down. And finally, redundant storage architecture, which maintains a secondary duplicate storage device that stays synchronized with the primary, providing automatic failover if the primary storage fails. Now, for question 3, which asks us to discuss the service load balancing architecture. The service load balancing architecture is essentially a specialized version of the workload distribution architecture. The key difference is that it is designed specifically for scaling cloud service implementations rather than general IT resources. So, here is how it works. Redundant copies of the same cloud service are deployed across multiple virtual servers. A load balancer then intercepts all the incoming requests from consumers and distributes them horizontally across those servers. The service itself can also include built-in load balancing logic, which lets it forward requests directly to neighboring service instances on other virtual servers without always going through the center load balancer. To support all of this, a cloud uses monitor tracks resource consumption and runtime data for each service instance. A resource cluster in active mode helps balance workloads across cluster members, and a resource replication mechanism generates new service instances whenever load balancing requirements grow, making sure the service stays available even under heavy demand. And finally, question 4 asks us to discuss the redundant storage architecture. The redundant storage architecture works by introducing a secondary duplicate cloud storage device alongside the primary one. These two devices are kept continuously synchronized through a storage replication system, so the secondary device always has an up to date copy of all the data from primary. If the primary storage device fails, a storage service gateway automatically redirects consumer requests to the secondary device. The secondary device then solves those requests through the LUNs, which stands for logical unit numbers, allowing consumers to continue accessing their data without any interruption or data loss. Oh, one thing worth noting is that the cloud providers sometimes place the secondary storage device in a different geographical region, usually to save cost. However, this can raise legal concerns depending on the type of data being stored. The distance between the two devices also matters because some replication transport protocols have stricter distance limitations, which affects how synchronization is carried out. And that covers all four questions for tutorial 4. Thank you for watching.